Is I audible to you?
Yes, sir.
Last day we have discussed topic name is in chemical kinetics.
Yes, sir. The chemical kinetics is over. So, new topic will be started.
Yes. Chemical kinetics is completed or some topic is left?
No, sir, it was completed.
Completed.
Chemical
New topic is
so molecular spectroscopy.
rotational. Yes, no.
Yes, sir.
First of all, what is molecular spectroscopy? What is physical spectroscopy and how many types of physical, organic, inorganic? Explain.
Sir, molecular spectroscopy is the study of the interaction between electromagnetic wave and the matter. So, in this case, in physical spectroscopy, we usually talks about the molecular spectroscopy, which in the molecule region. And so it is of three types. One is rotational spectroscopy, another one is vibrational spectroscopy, and another one is Raman spectroscopy. And in organic, we have UV visible spectroscopy and NMR spectroscopy. And in inorganic, we can see that there is ESR spectroscopy or EPR and Mossbauer spectroscopy.
Yes, good. First of all, we will discuss now discussing rotational spectra. What is rotational spectroscopy?
Sir, rotational spectroscopy is when the energy is changing for the rotation of a molecule, for a rotating molecule. If by rotation of a molecule there some changes occurs, then we can have some spectra from this from the changes. So in that case, we will consider the rotational spectroscopy. And it is under the microwave region. It comes under the microwave region. So the wavelength we got in this, it falls into this microwave region. So we call it also microwave spectroscopy.
Yes, rotational microwave. What the source of rotational spectrum?
The source means monochromatic, which is the light source.
Source means it provided energy initial to final excited. ग्राउंड स्टेट से जो एनर्जी प्रोवाइड की जाती है वही सोर्स माइक्रोवेव स्पेक्ट्रम में क्लेस्ट्रॉन एक यूज होता है सोर्स दिया जाता है एनर्जी का क्लेस्ट्रॉन What the selection rule of rotational spectra?
Sir, for rotational spectra, we can say that there are some energy level, and which is known as J. The energy levels are denoted as G, and the selection rule is plus minus 1. So it can have the the molecule transmit into from can transfer between consecutive rotational levels, not jumped into the another matter level. Means selection rule is plus minus 1.
Yes. First of all, basic, what is microwave active and inactive? What are the examples and why?
So for microwave activity, so in molecule there must be a permanent dipole moment present. Means in which molecule there is no dipole moment, there that molecule is a microwave inactive. For example, if we consider the molecule like H2, Cl2, or CO2. In that case, there is no permanent dipole moment present. So we can say that these molecules are microwave inactive. And the main for example that the molecule HCl or OCS, these molecules can have this molecule contains permanent dipole moment. So we can see that these molecules are microwave active.
Yes. Yes, selection rule of rotation spectra del J is equal to plus minus 1. Yes, no.
Yes, sir. Yes, sir.
Here is a J. Can we explain what the uses of J? How to determine of the selection rule in rotational?
Sir, J is the rotational level. We can denote the rotational levels as J. And if J equals to 1, then and by varying the values of J, we can have different energy values. So we can say that for level J equals to 0, we can have some energy which is E0 level energy. And for different J values, we can have different energy values. So this J is known as the rotational level. So and we know that the energy is quantized. So we molecule can exist in some uh, in in some particular steps, not in arbitrarily anywhere. And a molecule there can be the molecule can jump from one level to another level by supplying a specific amount of energy. So the levels in which the molecule can exist is known as the rotational energy levels, and this is denoted as J.
Yes, good. What the formula of microwave spectra of diatomic molecules?
So formula means energy formula.
Yes. Energy of a rotating molecule. Yes, yes.
Sir, so for a diatomic molecule, energy we can say that J is equals to H square by A pi square I J into J plus 1 joule. In the unit joule, we can say energy is equals to H square by 8 pi square I J into J plus 1, where J is the rotational level. And in the unit semi-inverse, we can say that the energy epsilon J is equals to J divided by HC, which is H by 8 pi square I into C is equal to C plus 1 semi-inverse, where H is the Planck's constant, I is the moment of inertia, and C is the velocity of light. And here J is the
Your
rotation.
board is not clear visible. I think light पड़ रही है. उस दिन लगाया था वैसा लगाइए अभी जैसे सेटअप किया है.
So is it visible?
Yes, yes, right. Yes. Yes, clear. Explain.
Say here, if we consider the energy value in joule, then we can say that h square by 8 pi square I j into j plus 1, where h is the Planck's constant, I is the moment of inertia, and j is the rotational value. And if we consider the value in semi-inverse unit, then and the energy value will be Ej by hc, and it can be h by 8 pi square I into c j into j plus 1. And we can replace it like b into j into j plus 1 semi-inverse, where b is known as rotational constant, and we can say b is equals to h by 8 pi square I into c.
Yes, good. Work constant. Yes, na. Work V. What the meaning of V here? Work constant.
So
What the,
b.
yes, B. What the uses of B? B. Yes. Work constant. Yes.
So, so B is here considered as a rotational constant, and in that case, if we calculate the value of any energy level, that means if we varying the energy of J, changing the J value, that means for epsilon J equals to 0, it will be B into J into J plus 1. Where if j equals to 0, then the value will be 0. And if we similarly for j equals to 1, we can have the value is 2p. And for j equals to it will be 6p. Sir,
Yes.
sir, from the value of b, means b is equals to h by 8 pi square I into c. That means b is inversely proportional to I. I is in moment of inertia, and we know that I is equals to mu r square, where mu is the reduced mass and r is the internuclear distance. Means if we consider a molecule or diatomic molecule, so if that is R1 and R2, this is R0, we can calculate that I, which is moment of inertia, is equals to mu into R square. So we can say that B is inversely proportional to 1 by mu. So in this case, if we consider the isotopic substitution, so we can there is significance of B. By this we can see the energy value or the peak value, the spectrum, or the gap between the two lines we can calculate, and we can measure.
Yes, good. Yes. What the formula of energy of a vibration energy levels?
सर वाइब्रेशन आज मैंने किया नहीं, पर मैं वो बस कर रही हूँ सर। आज मैंने रोटेशनल
Energy of a rotation energy levels can also be written in the formula. Rotation energy levels formula. Bj j plus 1. Yes. You written on upside. Yes. Vj j plus 1. Yes. What the uses of Vj j plus 1? E is equal to Vj j plus 1. What the uses of this formula in rotational?
Sir, for a rotational spectra, if this is equals to 0, in that case, E will be 2. So in the delta E, in this case it will be 2B, and in this case it will be 4B. Like this, it is increasing in order. So if I plot this in like spectra, then we will have this is 0. So we can show the molecular peak like this, and the gap between two consecutive molecular peak will be 2. So we can calculate the energy value from this, and we can also calculate the delta E from this equation also.
Yes, good. Next is what the energy difference between rotational energy levels? Energy difference.
Yes, sir. So energy difference means delta E. If we if the energy, if we consider from J1 to J2, then it will be sorry. So we know that the selection rule is delta delta J is equals to plus minus 1. So if we consider energy gap, then if the lower level is J, then the higher level will be J plus 1 in this case. And we can calculate this like epsilon J plus 1 minus epsilon J. And from this formula, we can calculate it like this 1 minus P into J into J plus 1. So it will be J plus 1, J plus 2 minus J. So from here, the formula is 2 into B into J plus 1. So here J is the value of the lower rotational energy.
Yes, good. What the uses of this formula in rotation spectra? Vj j plus 1.
So in this case, we usually depict when we consider the rotational spectrum. In that case, we usually consider the gap it means the energy gap is like the amount of energy we have to provide to move from the lower level to higher level. So in this case, we usually calculate the energy gap. That means the amount of energy we have to provide. So from this, we can calculate the energy delta E value, which we have to provide.
Yes, good.
And
Yes, what is the formula of alpha degeneracy of a rotational energy level?
sir, alpha degeneracy means only degeneracy.
Yes.
So degeneracy is 2j plus 1, which is the rotational.
Yes. What the uses of 2j plus 1? This formula.
Sir, in this case, usually, um, sir, sir, we used to calculate the population in a particular level. So for this, we used to consider the Boltzmann distribution formula. So for Boltzmann distribution formula, we know that we usually calculate the relative population of two levels. For this, in J by MC, it is proportional to degeneracy into so in this case we used to calculate the relative population. For that we have to know the degeneracy. So degeneracy of the both the level can be considered. So it will be the degeneracy ratio should be considered. So the degeneracy means in which in a level the energy value will be same for how many level the energy is same is called the degeneracy. So from that we can have from the value of J we can calculate the how many level for which the energy value is same, which is known as degeneracy. It breaks into some other subcell for which the energy value is same.
Yes, good. Jmax. How to determine Jmax value?
Sir, this is the population. So if we consider the population is population in a particular state, we can consider like 2j plus 1, which is degeneracy into minus Ej by kt. So if this is the value of population, so we can calculate the maximum population, and for maximum value we can have the Tp Tj will be 0. To get the maximum, we have to we should get the differentiation value which is equals to 0. So if we calculate this, so Tp Tj will be J plus 1 into HC. So here, we can write minus so if you calculate it, then we know that for maximum value it will be 0. And so after differentiating this with respect to dz, we will get the Jmax value. And Jmax value means the rotational level in which the population is maximum, or that means in which the intensity of the peak will be highest.
Yes. Next, what is the difference between a rigid rotator and non-rigid rotator in rotation spectra?
So usually for the energy value in a rigid rotator, when we consider a rigid rotator, we consider that the internuclear distance is fixed. That means it is rigid. For the rotation, any type of rotation, the intermolecular distance is not change, will not change. But in reality, no molecule is rigid because we know that the bond is elastic. There is to some extent of elasticity in bond. So the non-rigid rotator is when the internuclear distance will change with the different modes of rotation. That means by rotating, the intermolecular distance will change in case of non-rigid rotator.
Yes, good. Next one unit is a centimeter inverse. Yes, no. What is energy
Yes.
levels in unit is centimeter inverse? How to determine
Yes, sir.
the value of centimeter inverse?
So from Joule, so because if energy is in Joule unit, then in centimeter it will be like EY divided by 8, so you can get centimeter inverse. So since in spectra, we can see the value of value in centimeter inverse, which means which is in the which is in the terms of wave number. So we used to have the value in centimeter inverse. And for that, if we have the energy value in Joule, we will divide it by H into C. H is Planck's constant, and C is the velocity of light. We can get the value in centimeter inverse.
Yes. Next question is microwave spectrum of a rigid rotator and non-rigid rotator.
Yes, sir.
What the value of lines, rigid and non-rigid rotator, microwave spectrum value?
So for rigid rotator, we know that the energy value is V into J into J plus 1, where we consider that the internuclear distance is not changing. But for non-rigid rotator, value is this one minus J square into J plus 1 square. So in case of non-rigid rotator, it will be for E0 it will be 0. Equal to 1 it will be into be minus in this case T into 1 square into 1 square, which is be minus so here D is known as centrifugal constant.
Yes.
So, if we increase the value of J, then for in case of non-rigid rotator, we know that the value of D is very less. But if we increase the value, if we consider the higher value of J, then this part will be significant more. So with the increase, with the higher value of J, the total value of energy will decrease with respect to the rigid rotator. So we can depict it by graphically also. Means we can show the energy levels also. So the energy levels will be if we consider we will see that there is some decrease in energy. Will be 0. So we can see that with increase in J value, the energy will decrease more with respect to the rigid rotator. So the spacing between the energy level, which was the equal energy level space in case of rigid rotator, the spacing was equal. But in case of non-rigid rotator, the value will not be equal. It will with increasing J, the energy gap will decrease. And it will not be the same for all the energy, all the spectrum.
Yes. What the formula of centrifugal constant D?
Is equals to So I'm not sure, but I think T will be H cube divided by 32 pi square, pi to the power 4 I square into R square.
D is equal to 4VQ upon V bar square.
So H cube divided by 32 pi to the power 4 I square R square. And we know that B is equals to H by 8 pi square into I. So we can replace it with respect to B also.
Yes, yes. V is equal to, yes. But D formula is D 4VQ. 4VQ upon V bar square.
Yes, sir.
Centimeter constant.
Yes, sir. If we consider PQ, then it will be HQ.
No, D. Formula is D is equal to 4VQ upon
Yes,
V
sir.
bar square.
Yes, sir. We can replace it by from this B value. So 4PQ divided by what is
Yes.
it?
4VQ divided by V bar square. V bar square. Vibration frequency of the bond. Yes. V bar square. V bar V Victor. Vibration frequency of the bond. V bar Victor.
Yes, sir.
What the uses of this formula? Do you have any idea?
Sir, because in reality, no bond. We calculated the energy value considering that the molecule is rigid. But in reality, no molecule is rigid because in every molecule there is some extent of elasticity. So to calculate the value of energy, we considering that the intermediate distance is changing. So this formula is this formula is considered, and in microwave region, from this value we will get the spectra with respect to this region. We will have
Yes.
spectrum.
Yes, next day we will discuss some अभी discuss कर लेते हैं कुछ rotational spectra of polyatomic molecules. Yes, linear, symmetric, asymmetric, spherical top. What the
Yes,
uses
sir.
is one? Yes, polyatomic molecule. Yes, explain
Yes, sir.
some basic part.
Yes, sir. Sir, there are 4 types of molecules in which we can see the rotational spectrum. One is linear molecule in which like HCl, which is diatomic, and we can have OCS also, which will be polyatomic. And the another type is symmetric top molecule. And symmetric top we have 2 types. One is prolate and another one is oblique.